Hello everyone, welcome back to episode 2 of the Jockey mini-series. Today we'll be deep diving into the Jockey Arena. And so what the Jockey Arena is it's a little bit of an internal tool we built here at TwelveLabs that compares TwelveLabs' Jockey model against other leading large language models in the video space. And so specifically, you can think things like Google Gemini that accepts video as one of their modalities, AWS Nova that's purpose-built for videos, and all of these other large language models that ingest video. And essentially, what this arena is going to do is it's going to allow you to compare the inference between the two models on the same video corpus. And so this is reusing the same video corpus as last time from episode 1. If you haven't already watched episode 1, I really encourage you to watch that episode as it dives deep into a lot of concepts behind Jockey and how to actually not only implement Jockey in Python, but on how specific Jockey concepts work to maximize the performance of Jockey. And so, yeah, these assets are all indexed into our Jockey knowledge store, and both of these models will be sent the same videos. And so how this arena actually works there, after having all these videos indexed, is that you'll be able to see side by side which inference quality is the best, as text is a little hard to mathematically judge which one's better. But on the math side, we're going to be comparing things like latency, tokens, as well as the costs of actually running an inference with this specific batch of videos. And so every single large language model out there has their different pricing schema. Some charge by the tokens, some charge, especially when it's dealing with videos, by frames per second, depending on the video quality. And so this arena will take into account all of those variables so that you can see which large language model is best for your use case. And so just as a reminder, all of the code is open source for this entire web application in 2-VLM arena. If you haven't already, I highly suggest that you clone this repository and check out some of the code yourself as it dives deep into the Jockey implementation, as well as the benchmarks and how we're actually comparing models on the back end. And so this site is also deployed, TwelveLabs-jockey-miniseries.vercel.app. And by the time you watch this video, there might be more models added on. So feel free to check it out as well. And so before I start the prompting, I do want to introduce the code base just a tad bit. And the key thing being you can actually add your own models if you would like as well. It's very easy to add models in the sense that every model is just encapsulated within their own API route. We have Gemini prompt, Jockey prompt here. And as you can see, Gemini prompt is a very simple, basically straight from their documentation of a Gemini 2.5 flash call. And so if you want to change up which model you're comparing, you want to add more providers to compare it, feel free to, of course, clone this repository. And so with that being said, I think we are ready to run our first prompt. So you can see we're going to be sending all these videos to both Google Gemini and Jockey. In the future, of course, if you click this drop down, there will be more providers. Our next provider that we're planning to add is going to be AWS Nova. So keep a lookout on that. And so we're going to try to ask something that requires all these videos to be indexed. As that's the key strong suit of Jockey. It's not, of course, video level understanding is very good at, as it's relying on Pegasus and Marengo, but Jockey really also specializes on corpus level understanding, in which it can understand all these videos at once, as if they were almost like one singular piece of video footage. And so, since these are all on the Portugal World Cup soccer team, I'll ask something about Cristiano Ronaldo. So I'll ask, tell me what Cristiano Ronaldo did in each of these highlights. Be specific, like headers, goals, etc. So when we send that, you'll see that this comparison metric pop up. And you'll see that some of the metrics that we're going to be comparing is time to first token, total inference time, estimated costs, and throughput. But you'll notice here there's a little error that pops up from Google Gemini. It says only 1 of 6 corpus videos sent to Gemini. And that's because after extensive testing and really trying to get Google Gemini to work here, Google Gemini has a strict input token limit. And we can see Jockey's already responded here with specifics, but we'll dive into that in a bit. But Google Gemini and many of these other large language models actually have a strict input token limit, and videos hit that token limit very quickly. And so that's one of the common problems you'll face when you're not using a specialized video AI agent similar to Jockey. A lot of these models are built for text first, and so they might not be able to handle these long form video content. But we can see here on the left hand side for Jockey, it says in this Germany match, referencing this specific video, we can see some of the highlights. So we can see what did Ronaldo do in this match? We could see missed a strong near post header at that time. Let's see if he does.
Couldn't get it down.
No, that was a set play. All the Portuguese players end up running to the near post. Ronaldo scoops around the back, gets a great look. Very early lead back.
Yeah, and you can see within that timestamp, that's exactly what happens there. And you can see that this is pretty accurate and very specific. It references other players, it references the exact timestamp, and it also references all these different videos at once, all 6 of them. Now, if we compare the Google Gemini one, we can see for this one video, let's see if there's anything cool we can look at here. Ronaldo is visible on the field during VAR check for Germany's goal, and this occurs at 5:29. So let's see if that's true.
Referee.
5:29.
Being checked. No, I don't think that's a foul, personally, from there. I don't think he gives enough an extension of the arm. He's given the goal. Yeah. No, I don't think that's a foul, personally, from there. I don't think he gives enough an extension of the arm. He's given.
So yeah, it's a little confusing just because the video quality is a little low as well, but it's not really specifically broken down for Cristiano Ronaldo, which is the player that I prompted to focus on. But I do imagine that a lot of these timestamps will be pretty accurate as well. And so, of course, the inference quality is very, I guess, subjective in the sense that there's no really one correct answer. Some people might really prefer that Google Gemini broke it down in these very tight timestamps. And that, of course, is all fair game as well. But yeah, so that's the point of the arena. You can actually compare these outputs side by side and see which ones you like better. And you can see here that comparing Jockey and Google Gemini, Jockey was, of course, the first to respond. They responded way quicker than Gemini in this case. But it does cost a little extra. But you do have to remember Jockey took in all 6 of these videos, while Google Gemini just took in the first initial 13-minute clip. And so, yeah, that's pretty much it for this video. It is just meant to introduce this platform, get you guys to start experimenting with other providers, seeing which video large language model you do end up liking the most. And yeah, so if you do end up making any contributions, adding more providers, feel free to make a new PR to this, and I'll go ahead and take a look as well. And with that being said, see you in the next episode.